Assalamualaikum and hi everyone. For chapter 6, network architecture part 2, we're going to learn about the mobile IP for IPv4 and also IP. Okay, first to understand up until mobile IPv6, you have to watch the video that I have put that shows the technologies from 1G, the first generation, to 5G. And then we're going to learn about the definition of mobility in network, and then elements of mobile IPv4, what made up the mobile IPv4, the phases in mobile IPv4, the drawbacks and also inefficiency in mobile IPv4, and finally we're going to look at the latest technology, which is the mobile IPv6. Okay, so this is essential in order to understand the next topic. So I have put the link for this video also on the e-learning. So please watch this video first, then you can proceed to the next slide. A physically mobile user will present a very different set of challenges to the network layer. It depends on how that user moves between the point of attachment to the network. Okay, let's see one example. A user that carry a laptop with a wireless network interface card around a building. For example, you are using a laptop, okay, and you move around the building, and you move around the building from one location to another location. So from a network layer perspective, this is not actually mobile. Okay, you are not a mobile user, because if that user move within the same building and using the same access point regardless of the location, okay, from the perspective of the link layer, this user is not even mobile, okay, because this user is using the same access point. Okay, and another example here, okay, consider a mobile user, okay, that is on the who is on the vehicle on a highway with 110 kilometers per hour speed, passing through multiple wireless points. Okay, and this user also wants to maintain an uninterrupted TCP connection to a remote application throughout the trip. Okay, for example, this user. So this user basically, and also definitely a mobile user. Okay, another example is a user who takes a laptop from one location, for example, from your office, into another. Okay, for example, coffee shop, okay, or classroom, and wants to connect into a network in the new location. So this user is also mobile from the network perspective. Okay, so we can see that the difference between the mobility of the user from the network perspective, even though that user is using a mobile device, okay, and moving within the building, okay, it can be considered as no mobility because they are using the same access point. Okay, so mobile user connect or disconnect from network using DHCP, which we have learned from chapter 4. So the main problem that must be solved in providing mobile communication here using the TCP/IP protocol is addressing. Okay, why? Because the original IP addressing was based on the assumption that a host is stationary, which is attached to one specific network, and a router will use an IP address to route an IP datagram. And this host in the internet does not have an address that it can carry with itself from one place to another. For example, you are not allocated one specific IP address, even though if you, for example, if you want to use it at your office or at your classroom, and then when you go home, you are not going to use the same IP address. Okay, the original IP address is allocated based on the assumption that a host is stationary. Okay, so that address is valid only when the host is attached to the network. Okay, so if the network changes, the address is no longer valid. So routers will use this association to route a packet, and they will use the prefix to deliver the packet to the network to which the host is attached. Okay, so this basically works with stationary host. Okay, if for the original IP addressing. So what happens when a host moves from one network to another? This is where the IP addressing structure needs to be modified. Okay, so for approaches in addressing in mobile IPv4, the feasible approaches are to use two addresses. Okay, home address, and also care of address. So for the stationary host, it only have one address. So for the mobile user, okay, they will use two addresses. Okay, home address is the permanent address. Okay, it associates the host to its home network. For the care of address, it is a temporary address. It associates with foreign network. Okay, it changes as mobile host moves from one network to another. Okay, so when a mobile host visits another network, it will receive its care of address during the agent discovery and also during the registration phase. Okay, and this home address is permanent. Okay, it belongs to the host when it is attached to its home network. Okay, so we will see here the elements of mobile IPv4. Okay, so these are the terms that you need to know. The first is home network. Home network means the permanent home or original home for that mobile user. Okay, so this is a mobile host. Okay, for example, this is the address of the home network. The home address is address in this home network, address of this mobile host in this home network. So this blue color shapes here shows the home network. Okay, so address in home network can always be used to reach this mobile host. So this is the mobile host. Okay, for example, this is the address of the this mobile host in its home network. Okay, home agent, it refers to the entity that will perform mobility functions on behalf of mobile when mobile is remote. So we can see that this home agent normally is a router. Okay, another mobile host can also act as this home agent. Okay, so basically the home agent acts on behalf of the mobile host when a remote host sends a packet to the mobile host. Okay, and also it will receive the packet and sends it to the foreign agent. So what is foreign agent and what is remote host? Okay, so another elements here, remote host is the user that wants to communicate with the mobile host. Okay, and for the another terms here is foreign or visited network. Okay, just now we have identify the home network, which is here. Okay, so for the foreign network, it is a network in which the mobile currently resides. Okay, or in which the mobile is currently attached to. Okay, and home address will remain constant for this mobile host. Okay, however, it will be allocated another type of address, which is care of address. Okay, this is the address in the visited network. Okay, foreign agent is the entity that in that visited network or in that foreign network that performs mobility functions on behalf of the mobile. Okay, so foreign agent here is usually a router attached to the foreign network, and it receives and delivers packets sent by the home agent to the mobile host. Another role of the foreign agent here is to create the care of address. Okay, the care address for that mobile host. Okay, with the network portion of that care of address, or we call also as COA, with the network portion of the COA matches that of the foreign network. So there are two addresses associated with the mobile host, home address, and also care of address, or sometimes known as a foreign address. Okay, so the mobile host can also act as foreign agent. Okay, in other words, the mobile host and the foreign agent can be the same. However, to do this, a mobile host must be able to receive a care of address by itself, and this can be done using a DHCP. Okay, in addition, also the mobile host, if it wants to be the foreign agent, it needs another software, okay, to allow it to communicate with the home agent and also to have two addresses. All right. Okay, so when the mobile host acts as a foreign agent, the care of address here is known as co-located care of address. Okay, so there are a few of mobile IPv4 phases. Okay, so it consists of phase 1, agent discovery, phase 2, registration, and phase 3, data transfer. So to communicate with a remote host, a mobile host here have to go through these three phases. Okay, the first in agent discovery involve the mobile host and also the home agent and also the foreign agent. Okay, So it has agent solicitation and also agent advertisement. Okay, and also the same process, agent solicitation and agent advertisement when mobile host move to another network. Okay, for phase 2 registration, it involves registration request and also registration reply, and finally at the data transfer. So we will look at these three phases one by one. Okay, so for agent advertisement, when a router advertises its presence on a network using ICMP router advertisement, so recall that in ICMP we have learned on the router advertisement, it can append an agent advertisement to the packet if it acts as an agent. Okay, so in other words, if the router also acts as an agent, it can piggyback the agent advertisement to the packet. Okay, so mobile IP does not use a new packet type for agent advertisement, so it will use the ICMP router advertisement. Okay, and a router advertises its presence on a network using this ICMP router advertisement. For agent solicitation, when a mobile host has moved to a new network and has not received agent advertisements, it can initiate an agent solicitation using ICMP solicitation message. Okay, this is used to inform the agent that it needs assistance, and basically mobile host will listen for predict router advertisements, okay, or send a solicitation to discover the nearest router. And if this router is not the usual address of the router when the mobile host is at home, so it must be a foreign network. And if this router has changed since last time, the mobile host has moved to another foreign network. So the same mechanism that mobile hosts find their home agents. So basically there is processes involved in the agent discovery. Okay, now for the registration. To register with the foreign agent and the home agent, the mobile host uses a registration request and also registration reply. Okay, and also to get the care of address or COA on the foreign network, a mobile host can use DHCP. So a registration request is sent from the mobile host to the foreign agent, okay, to register its care of address and also to announce its home address and home agent address. So basically this is done upon entering the foreign network. Okay, the mobile host will directly contact the foreign agent, okay, through this registration request. So the foreign agent, after receiving and registering the request, relays the message to the home agent. Okay, basically it wants to say to the home agent that this mobile is resident in my network. Okay, note that the home agent now knows the address of the foreign agent because the IP packet that is used for relaying here, okay, has the IP address of the foreign agent as the source address. Okay, so a registration reply is sent from the home agent to the foreign agent and then relate to the mobile host. So the reply here will confirm or deny the registration request. So at the end of these processes, foreign agent will know about the mobile host. Okay, it will aware of the existence of this mobile host within its network, and also home agent will know the current location of this mobile host. Okay, so for the data transfer, okay, first we look at the data transfer from the remote host here to the home to the mobile host. Okay, so let's say here the remote host here wants to send a packet to the mobile host. Okay, right. So first, when this remote host wants to send a packet to this mobile host, it will use its address as the source address. It means that it will use the remote host as the source address, and also it will address this for this mobile host. It will use the original home address of this mobile host as the destination address. Okay, so I repeat, in other words, the remote host here sends a packet as though the mobile host is in or is at home network. Okay, because this remote host does not know that this mobile host has moved to foreign network. Okay, so remote host only know the IP address of this mobile host in its home network. So the packet, however, is intercepted by the home agent, which pretends it is the mobile host. So this is done using the proxy ARP technique. So you have learned about the ARP before, okay, in the previous chapter. Okay, so the next process here, what happened is when the home agent intercepts the packets, it will forward to the foreign agent using the tunneling concept. Okay, because this home agent already know or already registered that this mobile host has moved to another network through the registration process that we have looked just now. Okay, so upon receiving the packet, the home agent sends the packet to the foreign agent using the tunneling concept. Okay, so the tunneling concept we have learned before in IPv6, in which the home agent encapsulates the whole IP packet inside another IP packet using its address as the source and the foreign agent's address as the destination. So this is what it means by the tunneling concept. So when the encapsulated packet arrives at the care of address, the outer IP header will be removed to reveal the original packet. Okay, and then the next process is once the foreign agent receives the packet, it will forward the packet to the mobile host. Okay, however, first it will remove the original packet first. It will perform the decapsulation process, and when it sees that the destination address is the home address of the mobile host, the foreign agent here will consult its registry table to find the care of address of the mobile host, because the foreign agent here has to keep a table which map from the original home address for this mobile home for this mobile host to the care of address. So the packet is then sent to the care of address. Okay, and then if the mobile host wants to send packet to remote host, okay, it can send the packet as it does normally. Okay, for example, if this mobile host wants to respond to that packet that it has received, it can just do it normally. Okay, so the mobile host prepares a packet with its home address as the source and the address of the remote host as the destination. Okay, please note this, that the mobile host will not use its care of address at its source. Okay, it will use the packet with its home address as the source, original home address here. So although the packet comes from the foreign network, it has the home address of the mobile host. Okay, so there are inefficiency for this mobile IPv4 resulting from the processes that we have shown just now. Okay, it can be inefficient because of double crossing and triangle routing. Okay, for double crossing, it occurs when a remote host communicates with a mobile host that has moved to the same network as the remote host. Okay, recall the example before. Remote host is the entity that wants to communicate with mobile host. Okay, so let's say that this mobile host moved to the same network as this remote host. Okay, the easiest way is for the remote host just to send the packet to the mobile host using this path. Okay, it could be this path. However, the real thing that happens is when the mobile host sends a packet to the remote host, when the remote host sends a packet to the mobile host, it will go through the internet twice. Okay, first here it will send to the home address, so it will need the packet needs to go through the foreign agent here and also home agent here. So once the home agent intercept the packet, it will send back to the mobile host using the care of address of this foreign agent. So if you can see here, the packet crosses the internet twice. Okay, so if a computer here, since the computer usually communicates with other local computers, the inefficiency from a double crossing is significant. However, if the mobile host here wants to send a packet to the remote host, there is no problem and there is no inefficiency because it can do so as it normally does. Okay, the double crossing problem only happens when remote host wants to communicate with mobile host. Okay, if you see here, there's no inefficiency for this mobile host to remote host, and for remote host to mobile host, the packet will cross the internet twice. Okay, another problem that occurs when the remote host communicates with mobile host is triangle crossing. And this happens when remote host communicates with the mobile host in different network, which is not at the home network and also not at the same network as remote host. So when the mobile host sends a packet to the remote host, there is no inefficiency. However, when the remote host wants to send a packet to the mobile host, the packet will go through the remote host through the foreign agent here, okay, and to the home agent, and then to the mobile host. So the packet will travel the two sides of a triangle instead of just one side. So in other words, datagrams here addressed to the mobile host must be routed first through the home agent, okay, and then to the foreign network, okay, to the foreign network, even when a much more efficient route exists between the remote host and also the mobile host. Okay, so it could be this path. However, the packet goes through the home agent and also the foreign agent before it can be delivered to the mobile host. One of the solutions to mobile IPv4 inefficiency is by using direct routing. Okay, so for direct routing, remote host will bind the care of address to the home address. Okay, will bind the care of address to the home address. So when home agent receive the first packet for mobile host, it will forward the packet to the foreign agent, okay, for the first time, and then it will send the update binding packet to the remote host. So in future, all communication will be using a COA of this mobile host. Okay, so I repeat here. When the mobile node moves from one foreign network to another, okay, this can be solved by updating the care of address maintained by the home agent. Okay, with direct routing here, the home agent here queried for the care of address by this foreign agent only once. Okay, so home agent here is queried for the care of address by this foreign agent only once at the beginning of the session here. So remote host will request and also receive the care of address of this mobile host. And for the next session, it will send directly to the foreign agent here using this care of address. Okay. However, cache entry outdated once the mobile host moves to another network, and home agent needs to send warning packet to the remote host to inform the changes. Okay. And the foreign agent receive the packet and forward the packet to the mobile host. And mobile host will also reply directly to the remote host, okay, by using this direct routing. Like I said before, once the mobile host move, the cache entry will be outdated, and home agent needs to inform the changes to the remote host. Okay. Another solution is to use anchor foreign agent. Okay. Anchor foreign agent is the foreign agent in the first visited network. Visited network at the session starts. Okay. And data will always be routed to this first anchor foreign agent. Okay. And when mobile moves, a new foreign agent arranges to have data forwarded from all foreign agent. So this is like a chain process. Okay, so we see example here. Suppose that data is currently being forwarded to the mobile host. Okay, where the mobile host was located when the session first started. So this is the first network that this mobile host visited. Okay, when the session started. Okay, and this is remote host. This is remote host agent. Right. So the foreign agent in the foreign network will be identified. Okay, it means that the foreign agent in the first network that this mobile host is currently residing. Okay, this will be regarded as anchor foreign agent. Okay, so when the mobile host moves to a new foreign network here, okay, this is a new foreign network, the mobile host registers with the new foreign agent. Okay, and the new foreign agent provides the anchor foreign agent here with the mobile node's new care of address. So when the anchor foreign agent receive an encapsulated datagram for the departed mobile node, means for this mobile node, it can then re-encapsulate the datagram and forward it to the mobile host here using the new COA via this new foreign agent. So if this mobile host later move to another new foreign network, the foreign agent in that new visited network will then contact this anchor foreign agent in order to set up the forwarding process to this new foreign network. Okay, so this process will be like a chaining process. Okay, and also this is easier because foreign anchor foreign agent here is already selected at the beginning of the session. Okay, next we will move to the mobile IPv6 architecture, okay, via route optimization. Okay, basically there are two techniques for mobile IPv6 architecture. One, the first technique, you can use the same technique as mobile IPv4, which is tunneling. Okay, and the second one is to use route optimization. So in mobile IPv6, each mobile node is always identified by its home address, unlike the mobile IPv4. So this is regardless of its current point of attachment to the internet. Okay, while situated away from its home, a mobile node can also be associated with care of address, okay, which provide mobile node's current location. So IPv6 packets addressed to a mobile node's home address are transparently routed to its care of address. And the transparent routed means others will not know that it has another care of address because this mobile node is only identified by its home address. Okay, and the protocol enables IPv6 nodes to catch the binding of a mobile node's home address with COA or with its care of address. Okay, the binding means to associate the home address with its care of address. So any packet destined or addressed to this mobile node is sent directly to its care of address. And for this mobile IPv6 architecture, there is no foreign agent in mobile IPv6, and it requires that every mobile node in IPv6 to support route optimization. Okay, and it also has address auto reconfiguration where it receives mobile prefix advertisement and reconfiguring its home address based on this prefix information contained in that packet. Okay, in mobile IPv6 also uses dynamic home agent address discovery. So when there is no foreign agent in mobile IPv6, okay, because in mobile IPv4 we have special routers that act as foreign agents. But for mobile IPv6, it operates in any location without any special support required from the local router. And the mobile IPv6 route optimization capability allows the mobile IPv6 protocol to coexist with the ingress filtering devices located at border gateway. So we will have a look at the ingress filtering after this. Basically, the ingress filtering is the process where a security measure, okay, intended to discard or to drop traffic that is seen to be malicious. Okay, and because some of the internet service providers check the source IP address of packet to see that whether they match where the routing protocol believe that the source should be located. So this is the ingress filtering. Okay, so this basically a problem in IPv4. Okay, but in IPv6, this can coexist with the ingress filtering devices which are located at the border gateways. So most packets sent to mobile node while away from home in mobile IPv6 using IPv6 routing header, okay, rather than IP encapsulation. So this will reduce the amount of resulting overhead compared to mobile IPv4. Okay, so moving on, for the packets delivery in mobile IPv6, okay, so for home address option in mobile IPv6, the host is using care of address as source address in the foreign links, okay, and this will not create any ingress filtering problem. So recall that ingress filtering, it's actually a security measure security measure for the routers that is intended to discard the traffic, okay, that is seems to have incorrect addresses because they think that it may be malicious. Okay, and for mobile IPv6, it defines a new routing header variant, which is called the type 2 routing header. Okay, so the remote host will use this IPv6 routing header rather than IP encapsulation. Okay, this type 2 of routing header allows the packet to be routed directly from a remote host to the mobile host care of address. Okay, so I repeat, this type 2 routing header allows the packet to be routed directly from a remote host to the mobile host care of address. Okay, and the mobile host care of address is inserted into the IPv6 destination address field. And once the packet arrives at the care of address, the mobile host retrieves its home address from the routing header, and this is used as the final destination address for the packet. And the mobile host registers its current binding at the remote host for cached binding. Cached binding means that a process to associate its home address with its care of address. Okay, this cache is maintained by home agents and also by the remote host. So the cache contains both remote host registration, okay, and also home registration entries. Okay, so you can see the details for mobile IPv6 process in RFC document, request for comment document 6275. Okay, so you can Google RFC 6275 to understand more about the mobile IPv6. When sending a packet to any IPv6 destination, the remote host checks its cache binding for an entry for that packet's destination address. So if a cache binding for this destination address is found, the remote host uses a new type of IPv6 routing header, which is this type 2 routing header, to route the packet to the mobile host by the way of the care of address indicated in this cache binding. Okay, and also the nodes or the remote host and also the mobile host in the mobile IPv6 supports route optimization naturally. Okay, and it means that in order to be able for this mobile IPv6 using route optimization to work, all the nodes should support this route optimization. Route optimization means the manner of delivering packets that does not require to go through the home network. Okay, instead it can send the packet straight to the care of address. It will enable faster and also more reliable transmission. And the mobile host needs to ensure also that the binding cache here, the binding cache entry exists for its home address so that the remote host can process the packet. And routing packet directly to the mobile node's care of address allows the shortest communications path to be used. And it also eliminates any congestion at the mobile node's agent and also home link. Okay, if you remember, for the mobile IPv4, all the packets has to be intercepted at the mobile host home agent. Okay, so you can imagine the congestions that occurred at the mobile home agent. However, if using this route optimization, it eliminates this congestion. And also, in addition, the impact of temporary failures of the home agents or networks or on the path to or from the home agent is also reduced. So this is the mobile IPv6 route optimization. To support route optimization, mobile IPv6 requires each host and each home agent to use a binding cache, okay, binding cache or binding registry to maintain the binding information received from the mobile host. And when IPv6 terminal wishes to send a packet to another IPv6 terminal, it needs to check its binding cache first to see if it has a binding for that destination. And if it does, it can address the packet to the destination's care of address directly. If it does not have any binding for the destination, it will address the packet to the destination's home address. Okay, so initial packets are addressed to mobile home address, okay, and packets addressed to a mobile home address are captured by this home agent for the first packet. It will be sent using tunneling, okay, from the home agent to the care of address. This is just like MIPv4. However, for the subsequent packets, it can be sent directly between mobile host and also the corresponding host, because it has it has already update its binding cache. Okay, binding cache, and also it needs also to maintain this binding cache. Okay, this is what I have been explaining before in previous slides. Okay, so the binding cache is using this binding acknowledgement and also binding update. So mobile host sends binding update to its home agent to register its care of address. So this is done periodically until the recipient of the acknowledgement. Okay, so once it is it receive the acknowledgement, binding acknowledgement from the home agent, then the mobile host stop sending that binding update. So this is done every time the mobile node moves into a foreign network. Okay, so every time it moves into a foreign network, it will acquire a IPv6 care of address from the foreign network and use it to receive packets from the foreign network. Okay, and to ensure, remember that to ensure that a mobile can continue to receive packets addresses to its IPv6 home address, the mobile will register its current care of address with its home agent. Okay, using this bind cache. Okay, bind cache process. Okay, means that the association between a mobile's home address and its care of address. So each time it updates its care of address, it needs to send this binding update to home agent. Okay, and needs to wait for the binding acknowledgement from this home agent. Okay. So once the mobile host move to the location, okay, or to detect a movement of the mobile host, okay, IPv6 uses neighbor discovery. Okay, so this includes router discovery and also neighbor unreachability detection. So neighbor unreachability detection is to detect when the default router is no longer reachable. Okay, no longer bidirectionally reachable. And so in which case the mobile node must discover a new default router, okay, for that link. And for the router advertisement message, this carry, among other information, the IPv6 address. Here, the router advertisement message, it carries the IPv6 address of the router and network prefixes that can be used by mobile hosts to configure their care of address. Okay, and the information in that router advertisement message allows a mobile to discover the new IPv6 routers, and it also helps a mobile host to detect whether an IPv6 router is still reachable or not. Okay, and also it can also help the mobile host to detect whether it has moved out of a network or whether it has moved into a new network. Okay, means it helps that mobile itself. Okay, using this router advertisement message. Okay. While away from home, a mobile host selects one router and one subnet prefix advertised by that router to use as the subnet prefix in its primary care of address. Okay, so this can be done also by listening to that router advertisement message. Okay, so mobile host can wait for the periodically router advertisement message to select its router. Okay. So a mobile host also uses other information to help determine whether it is still reachable from a router. For example, the fact that a mobile node just received any packet from a router, it can be used as an indication that the mobile host is still reachable from that router. So that is basically the process of mobile IPv6. So again, in order to be able to use this technology, all nodes has this IPv6 technology, has to support this IPv6 technology, and also has to support this IPv6 route optimization. Okay, and for another option is just to use the same method as MIPv4. Okay, so that's all for this chapter. Don't forget to scan your attendance here. Okay, don't scan it using UTM Smart application, but scan it using your phone. It will forward you to a new link, okay, so that you can fill your details and also mark whatever whatever video lessons that you have watched for this chapter. Okay, so thank you very much.